So if we just take a look at Year 5-6 addition now. So when the children move into Year 5-6, they will begin to work with a formal version of the column addition method. The children have already been introduced to the basics of the method in Year 3-4 and then built upon this, in Year 3 and then built upon this in Year 4, where they've developed a really deep understanding of the place value within the method and why the method works. In Year 5-6, that place value knowledge is embedded. The children understand why they are doing what they are doing. So we're no longer recording it in an extended way. We're no longer blowing the number apart into hundreds, tens and ones, for example. We're no longer recording in just ones, tens and hundreds when we come down to the bottom of the method. So the method itself will look shorter, but the same knowledge is required to be able to complete it. We just don't record it by writing it down anymore. So when you come into Year 5-6, the children are starting to work with numbers up to 5 or 6 digits. So we might have, let's say, something that looks like this. So 74,325. And actually we might add something with a different number of digits here. Let's go for something like a, let's go for a 4-digit number. If we do a 3,472, something like that. Really important to teach the children, this is tens of thousands, sorry, thousands, hundreds, tens and ones. Really important to teach the children to line those numbers up correctly in the columns. A misconception that may arise is that they'll automatically line everything up to the left. I guess that's kind of natural because we write from left to right, don't we? Whereas in maths we work from right to left. It's a little bit different. So there's 74,325 will look like this. We have 7 10,000s, we have 4 thousands, we have 3 hundreds, we have 2 tens, and we have 5 ones. The misconception then being that when we come to the 3,000s in this number, they'll automatically line it up to the left, looking like we have 3 10,000s rather than 3,000s. So just something to be aware of in case it crops up. We want to be establishing that this is 3 thousands in the number, 4 hundreds, 7 tens, and 2 ones. Hopefully that could just be a quick discussion at this age, but if not, we could be putting the place value headings over the top just to make that a little bit clearer for the children. And then we are adding. And a very simple example here with no exchanging because the columns don't total over 9. I simply just move from right to left and add the columns. So 5 and 2 is 7. 2 and 7 you might say, but actually what we prefer to be saying is still the language related to the place value. This isn't actually 2 and 7, it's 20 and 70. It's 2 tens and 7 tens. So we normally say 2 tens and 7 tens is 9 tens. 3 hundreds and 4 hundreds is 7 hundreds. 4 thousands and 3 thousands is 7 thousands. And 7 tens of thousands is 7 tenths of thousands. We'll be looking in 5-6 as well for them to include the comma within the number. So they should start to know that when we move from the right, it's every third digit. So 1, 2, 3. And a comma. Everything to the left of the comma, or everything to the left of the first comma, is thousands. So we can easily read that as 77,000. And then, of course, the 797 for our total. We might have an example with exchanging. So if I quickly just show you one of those. Let's go for another 5-digit number. 7,395. Oh, sorry, I said 4-digit number, 5-digit number. So let's go for 73,952. We'll go for a different number. Again, I don't know, maybe 389, let's say. Again, we would want the children, 10,000s, thousands, hundreds, tens, and once again, we would want the children lining those up under the place value headings, just to make sure that their placement of the digits is correct first of all. When we start to look at some of the SATS papers in Year 6 and we go through the calculation paper, the first paper is purely just calculations. the number of marks that are lost in the early stages of the practice, where the children know the method, they can complete the addition perfectly fine, but they haven't lined the numbers correctly at the beginning, the number of marks lost is crazy sometimes. It's always an area that we need to address to move forward. And it's just not worth it. If you know the method and you know the maths and you're putting in the time to answer that question, let's get that first part right so we know we're on the right track. So in this number then, let's line it up. We have 7 tens of thousands, we have 3 thousands, we have 900s, 5 tens and 2 ones. And we're going to be adding on 3 hundreds. Important, it goes here in the hundreds column, not over here automatically to the left. We have 8 tens, we have 9 ones. Again, you might just want to put the place behind your head over the top to support that knowledge. Total line then, addition symbol for addition, and we're totaling the columns. Oh, I've gone wrong. That should be a 9. Just correct that quickly, there we go. Okay, so we now have 2 ones and 9 ones, which total, of course, 11 ones. By now the children are secure in their knowledge to know that is 1 1 and 1 10th. And we start to record like this. We have 1 1 and the 1 10 coming over into the tens column. So we now have 5 tens and 8 tens, which together totals 13 tens. Really important that they remember to add on that extra 10 that we exchanged from the ones column. Is often forgotten. Again, an area where mistakes can be made. What we do is get the children to cross it out as they've used it so they know it's been used and it's not forgotten. So actually 1 more 10 gives us 14 tens, which is equivalent of 4 tens and 10 hundreds, which I'm going to carry over into my hundreds column. And then have 9 hundreds and 3 hundreds, which is 12 hundreds, not forgetting that extra 100, which is 13 hundreds. There we go, there's the hundreds, and then carrying over that 10 hundreds into the 1,000 column. And I have 3,000 and 1,000 equivalent to 4,000, 7,000, and of course, not much there. It gives us a total of 74,000, crikey, 74,341. If we're looking at